Today, as we talk about in section 2.3 about direct variation, we're going to compare the ideas of equations that are functions but may or may not have a direct relation between the numbers involved in the function. Very straightforward. A direct variation problem is an equation that has the equation y equals kx. And y equals kx should be something very familiar. You may think of it as something like y equals mx. But what I want you to realize is it does not have what is written here in red. It does not have the plus b. So if it's direct variation, it's just going to be in the form y equals kx or y equals mx. The variable k can't be equal to 0, so you can't have an equation like y equals just a number, but it does have a value. And if we were just going to find the value of k by itself, you'd just say, hey, what's y divided by x? And that number, y divided by x, is going to be a constant, a consistent number in the problem. And that constant variation is called k. So sometimes you're given 3 of the 4 pieces of information. You're just going to set up a proportion, y over x equals y over x, with corresponding number parts going in there. You're going to cross multiply and solve. We'll do a couple of those later. But first, let's do some identification of when it is or is not direct variation. Once again, remember, we're looking for, very simply, equations that can be written in the form y equals kx. And I can't emphasize enough, it has to be in that form and not have a plus or a minus number at the back. So here we go. In our first example, we're going to look y equals kx. Well, y equals kx. Obviously, this is in the form. The value of k is 10, and so the answer to this is going to be yes. Okay? So here we go. Let's look at our second one. Now, this isn't in the form y equals kx, but perhaps we can solve it. Let's add 5y to both sides, giving me 2x equals 5y. Then let's divide both sides by 5, and that gives me y equals 2/5 x. And now very quickly we can see, yes, it is an example of direct variation, and the value of k is simply 2/5. Let's look at our third one. Y equals 1/3 x minus 4. Well, I'm going to highlight and circle our problem here, this minus 4. This minus 4 is a big issue. It does not let us be in the form y equals kx, so this is not an example of direct variation. So the answer to here is no. Down in the bottom left-hand corner, we have y equals 8x if we add 8x to both sides. And so very quickly you can see this is an example of direct variation. Yes, it is. And the value of k is 8. Let's look at our next one. If we isolate the y by subtracting 4, we're going to very quickly see 8x minus 4 equals y. And no, this is not an example of direct variation because it has that minus 4. Our last one, we have 3y equals 4x. If I were to divide both sides by 3, I would quickly see that y equals 4/3 x. And very quickly you're going to see, yes, this is an example of direct variation, and the value of our constant of variation is 4/3. So, in each of these cases, we've got to understand whenever we see a plus or a minus with a constant, up there or right there, we've got a situation where it's not direct variation. So, hopefully that's a quick summary that you'll be able to duplicate and recognize those quickly. Let's move on. In our next situations, we are going to be looking at when we're given 3 of the 4 pieces of information and we have to find the 4th piece. So in these situations, we're going to set up a situation where we're going to say y1 over x1 equals y2 over x2, and we're going to solve for the missing part. So here's my first group that I'm going to underline with 2 lines. And my second group is going to be underlined with 2 red lines. So let's set up our proportion. 6 over 2 equals 12 over x. We cross multiply. We get 6x equals 24. So therefore, x equals 4 very quickly. Let's look at example 3. We've got 7 over 2 equals y over 3. We cross multiply. 21 equals 2y. We divide by 2, and y equals 10.5. All you're going to do on these problems, once again, is you're going to set up a proportion. Remembering a proportion is when a ratio equals a ratio, and you're going to solve for the missing variable by cross multiplying. Our fourth example is we're asked to write an example of a direct variation with a constant variation of 3. Remember, our standard form is y equals kx. So if k equals 3, that means our equation is going to be y equals 3x, or y over x equals 3. I'm going to circle this one because this is probably the more normal procedure that you're going to see. Lastly, we're asked to write an equation of something of an equation that's a relation. Remember, that's just a set of ordered pairs. That is a function, but is not an example of direct variation. Well, the easiest thing that I can think of is the function y equals a line. Say 4x plus 3. Or y equals 4x minus 2. Or y equals any slope x, 5x plus 9. Basically, you can have anything that's going to have a plus or minus number. So mx plus b. So long as b does not equal 0, it's always going to work. So there's dozens and dozens of answers on these. Now, our homework tonight is 9 through 16 that we're going to work together momentarily, and then just 6 more additional problems that you're going to work on your own at home. All right, let's look at 9 through 16. Of these problems, which ones of these are very quickly identified in the y equals kx manner? Well, y equals kx, here we go. This one definitely is, and k equals 12. This one definitely is y equals kx, where k equals 6. Definitely y equals kx. What does k equal? -2. Number 12, that should be setting off large alarm bells because we have a +1, so this is not direct variation. Let's look down at 13. Once again, see that -3? Large alarm bells should be going, so that is not an example of direct variation. Let's look at number 14. Y equals kx? You bet it is, because k equals -5. 15 and 16, a little bit disguised. If we add 6x to both sides, it definitely is direct variation, and k equals 6. Lastly, do you need to solve this for y? Or can you identify the fact there is a +3 there, and that +3 is going to be a definite factor in telling us that yes, it is not direct variation. So, once again, we're going to highlight these issues that cause it. It's that +1, it's that +3, it's that -3, and those are the key ideas that are going to cause things not to be direct variation. So, as we wrap up and kind of come back to our top, first we solved to see if it was equal to y, and in the form y equals kx. Remembering you can't have that plus b. Second, we had problems we were given 3 of the 4 pieces of information, and we set them as a proportion to make an equation there and solve for the missing part for direct variation. And then lastly, we identified what makes a function to be an example of direct variation or not. I hope this has been helpful to you in understanding direct variation.